Okay, so in last session we have just opened up discussion about operating system, and what we have learned in last lecture session discussion is we have defined a formal definition of an operating system. So we have come across with two important terms. First term is operating system is an interface between user and hardware. Second important term which we come across is operating system is a is a system software. So collectively we say that in order to define operating system, we say that operating system is a system software and that acts as an interface between user and hardware of computer. Okay, so if this definition we take as a definition of operating system, then every operating system has certain goals, right? And the first and most important goal is to execute user program. So yesterday we have taken an example of executing a C program. So we have understood that for a C program you need a compiler, which is again one example of a system software, which does what, which takes a high level language input program and which will transform that or translate that particular program into machine readable form, and machine readable form is further being converted into an executable form. So whenever a user wants to perform a desired task, or user wants some task is to be performed from the computer, then definitely user come up with certain set of instruction which we called it as a program. Okay, so the purpose of writing program is to take certain output from a computer. So to handle this particular thing and get the user work done, operating system has to take care of lot many things. Okay, so out of that, the first major important goal is of an operating system is to execute user program and make the solving of user programs more easier. Now, in order to handle this particular thing, OS has to come forward with certain resources. Okay, resources that are required for a user program. So that resource is like, okay, what is, whether the appropriate memory size is available or not, whether my processor is available or not, okay, whether the user is performing performing a system in a sequential way, or it is sequential way, or it is a parallel way. So the program is either a sequential or parallel. Okay, so based on that the processor is being selected, so resources memories are being selected. Okay, whether the user program needs certain sort of IO devices, right, that has to be determined, whether they are available or not, that is again also determined. And the storage files and storage, right, whether they are required or not, it is like that. Okay, so in order to execute the user programs, OS has to decide the number of resources also. Okay, and one more responsibility of operating system is to make computer system convenient to use. So that is why you can see that the most operating systems are now shifted from a shell mode shifted from shell mode to UI mode. Okay, by UI mode means I say UI mode means what, user interface. So we are means almost all operating systems are now providing a user interface, and those interface are what you see is what you get. Okay, so this is the principle which we are going to have. Okay, so it is like what you see is what you get, right? So it is like this. So basically everything is coming on to this particular principle. So this is this is by providing a very good user interfaces. So which makes the things shifted from a shell mode to UI mode. Previously, you will find that Unix, Linux are on basically working onto a shell mode. A black screen used to come, right, and you need to do lot many activities there also. You need to go with a lot many activities at there also. So you have to understand this particular part that make computer system convenient to use. So the adaptability of the computer system must be high in this case. Okay, then the next most important point is you should use the computer hardware in more efficient manner. Okay, so more efficient manner means like give you one more example here. See, for example, if I have a printer here, say this is my printer, just to take a case that this is my printer, this is type of printer, right? Usually, if this printer is connected to one particular CPU or a computer like this, okay, so this is CPU. Okay, so one printer is connected to this CPU. This particular will become a single use. Okay, this become a single use, single user use actually. Right now, if I wanted to make this particular printer available for my network user, so if if I wanted to make this printer available for a network user, so which means that this particular printer becomes, say initially it was a single user use, so it becomes network means it has become a shared. So when this particular printer is become a shared resource, so when this printer become a shared resource, in that case this the use of this particular printer is effectively increased. So if this is shared use, then the usage is increased. Usage is increased. Okay, so we can say that this is effectively used. Initially, it was a single use, but later it is becoming available for all. So means in order to use a computer hardware in more efficient manner, we are going to use operating system. And who is taking this particular, who is taking lead into this? The operating system is taking lead into this particular mechanism. So the operating system goal is to execute user program and make solving of user program more easier by deciding the resources and their priorities and their available, making it available. Then make the computer system more convenient to use. As you see, like we have been shifted from a shell mode to UI mode, and the use of computer hardware in more efficient manner, which you can see. Okay, so if you look at this particular computer structure available, if you know the computer system structure, the most important structure that we are going to have a CPU, and CPU stands for what? Central
Processing
Processing
unit.
unit.
processing unit.
Unit.
Yes, CPU stands for central processing. Okay, and the central processing unit, what we have understood is that there is a certain IP, then this is going to be a CPU, and what you are going to have? Output. Okay, so we have a certain input being supplied to a CPU, central processing unit, and we are going to have a certain output. Okay, so this is actually a central processing unit. So there are input devices connected, there are some output devices connected. Okay, but if you look at this computer system, there are four particular components available here. The first component is like a CPU, which is nothing but a hardware part. Okay, now what is going to be here? If you look at this as an hardware, then you must have to understand like what are the significant components that exist here, right? So in case of this CPU, so this is first component. If you look at this particular component, is like you can have a processor, particularly most importantly you can have processor. Then second important part is you have storage. Okay, Third important part is you have memory. Okay, and fourth important part which you are going to have is devices. Okay, so this is processor, storage, memory, and devices. Okay, so these are four significant component here. When I say a storage, it is going to be, it is particularly for disk. Okay, this disk is like into devices itself. So these devices are broadly categorized into I/O, input, output, and storage. Okay, so there are three kinds of devices: the input devices, output devices, and storage devices. So in case of input devices, you must have a list of input devices. It starts with keyboard, you can start with mouse, you can have then joystick, then you can have stylus. Okay, right. If you look at this output devices, then you must be having monitor. Okay, then you must be having printer. Okay, so monitor, printer, these are two output devices, right? So if you look at storage, you have a disk storage. If you look at the processor, you have a you need to decide whether you are going with a single uniprocessor system or multiprocessor system or core processor system. Then you have a storage. Then you can, like, if you look at this particular disk storage, you can have, like, say, okay, removable, removable, right, or permanent, right, or connected permanent storage. Okay, so permanent storage we can say HDD, removable you can say pan, right, optical storage you can go for CD or like DVD, right? So these are kind of what, these are kind of storages. Now if you look at this memory, so in this case it is volatile storage, and this particular storage stands for random access memory, right? And this is going to be called as primary. This is called as primary memory. Okay, so means these all are being called as a hardware segment particularly, right? So CPU stands for central processing system, and this calls for hardware, and these all are hardware. Now, my hardware means like a component of system which you can touch and feel it, right? Which you can particularly touch, you can feel. Okay, so feel the physical existence particularly. So you have a physical existence here, right, of those. So this is really very important. Then you have a second component of this, is called as operating system. Okay, so which coordinates the activity amongst the hardware. Okay, so the operating system is particularly binds, this particular thing is binds all hardware in one, binds all hardware into one particular in or binds hardware in order to generate collective effort. Okay, in order to generate a collective effort. Now this collective effort is towards whom? Towards user task, right? So whatever the task user want to perform, for that particular task you need the collective effort from all hardware. Okay, so this is important. So operating system is there. Then next is that these application programs are being managed by, they are managed, they are being managed by operating system, right? They are being managed by operating systems. Okay, so this is what is important. So application programs. So just to take an example, all your Word programs, right? Right, there are inherent compilers. Say here, in this case, compilers are system software, right? But they are being integrated part of some applications software, such as, say, just take a case. You have a Visual Studio. Okay, so in this particular case, Visual Studio is an application software by which you can create different applications, right? But for that, for writing those platform programs, you need a for compiling those compiler and interpreter both are integrated, right? Interpreter both are integrated. Say for example, where compilers, like if you have VB.NET kind of mechanism, so there is an interpreter exist and you have a compiler also there. Okay, they are being included as an application program, and at last users are there. So what are these? Users are nothing but people, machine, and other computers. So in this case, what we are talking about, this we have discussed yesterday itself. So you have a hardware, then you have operating system, then you have uh, application software, right? And then you have user. So this is going to be a layered view. So simple case is that if you look at computer system architecture, it is a layered view. Okay, so this we have already seen, but as a matter of fact, for more discussion, we have included this one. Okay, so if you look at the four components of computer system architecture, it is like this. So this is at the first stage. So this, like if you look at the number, if you wish to give this number, so this is going to be 0. This is going to be 0. This is going to be 0. Then this is going to be a layer 1. Okay, this is going to be application software layer 2, and here at the outermost layer the user stands. So this is going to be here. Okay, so this is in case of application program, right? There are bundle of programs. Okay, different bundles available, bundle of applications are available, right? And there is like if you look at the access to this is like 4 to 0. So means what? The access is going to be the topmost point to the 0th point. So like this is how it is going to be converted. So this is you can take this is third layer, this is third layer, and this is 0th layer. So 0 to 3. So there are 4 layers. Okay, what actually operating system do here in this case? It depends upon the point. Means like there is lot of scope in putting this, right? It almost does everything. Almost does everything, right? Okay, so means what? Though you look at like though you said that you are using uh, application program, but this particular application software, but this is being managed by a system software, or you can say hardware. You can say system software, or you can say operating system. These are being managed. So whatever the resources that are required is being done by operating system. So so the answer will be as per the scope of point of view that is like you can define. Okay, so it offers user convenience. It offers a convenience to user, make the system more get the usable, and get the maximum throughput, right, or performance. So this is like throughput or performance. Now, when I say a good performance criteria, please try to understand that this criteria can be defined into two important segments, in two important ways. Right. So, good performance means what? Good performance means uh, low overheads, and maximum output. The good performance is always is that you should have a low overhead on the system, and that it must be a maximum throughput. So this is very good criteria. So this is important criteria. So whatever we are going to learn now or going to discuss about any of the method in operating system, we have to say that whether it is consuming low overheads. Now, low overhead means that the efforts by hardware must be low, right? So with the low effort, throughput of hardware must be maximum, right? So means with the minimum efforts, you want maximum output. So this is what is good performance is. Okay. So, and whenever we are doing this, we are really don't looking at the resource utilization, how the resources are being utilized. So in order to get low overhead and maximum throughput, these resources must be utilized in a proper way. But for these resource utilization, you need to decide a policy. You have to decide a policy. And who is going to decide this policy? Your operating system is going to decide this particular policy, right? And this particular policy, now here, this policy again referred as, you have to have a algorithm or a particular method, process, or particular method in which the resources are being utilized. Method by which the uh, resources are utilized. Okay, so still in this case, we are not really taking care of resource utilization. Okay, but we need to decide, in order to get a good performance, we need to decide the policy. And who is going to decide this particular policy? The policy is being decided by the operating system. This is really very important, that this policy is being decided by this operating system. Okay. No, it is like there are certain platforms also. Like there are certain computers which are shared also, like mainframe or mini computers, right? And they are being shared between number of users, and they try to make all users happy in that way. Okay, so similarly, you have a good workstation also with a dedicated resource. Say, for example, by workstation, I mean um, uh, like graphics workstations where some specific dedicated resources are also being available. So by that I mean, say for example, for a graphics workstation, you have a um, graphics card, right, which is uh, dedicated towards um, uh, enhancing graphics. Okay, graphics of system, right? So there are dedicated software graphics cards. So you have a NVIDIA graphics, or you have got uh, Redon graphics, right? So for just to give you an example, you have NVIDIA, right? Or then you have uh, Radeon, Radeon graphics. So this is AMD graphics. Then you have NVIDIA graphics. So they are dedicated. So they have their own mechanisms. Okay, so they have their own memory also. This graphics card comes with 2 GB, 4 GB of their own memory. Then you have GPUs also, right? So involved GPU. So means apart from the central processing unit or a processor, you have a graphics processing units also. So GPUs are also being there. Then there are like you can have servers also, right? So that are being shared for in between number of users. So they are handling the request and responses in that way. Okay. As far as now, if you look at compare with these mainframe mini computers, workstation servers, right? With laptops, you will find that in case of laptop, resources are managed in very poor way. That we all have to agree. We are taking core to DO and good processing unit, but we are using it for just drafting a letter. So means what, the resources are not properly managed, poor resource utilization we have, and they are not optimized with the usability as such, and they are being dependent onto a battery life, right? So if you don't have, like, say, because if you look at laptops and all those handheld computers, they are basically meant for giving you an access, right? Irrespective of, like, you don't want it to be connected for a power or likewise, because power bank is already available as a battery, but it is like not as per the satisfaction level. So it is like that. So the resources are poorly managed here. So some computers have little or no more no user interfaces, right? Such as, like, if you look as towards embedded computers, right? Or you have there are, instead of this embedded computers, you can also refer back this as a some control systems. So control systems have very poor UIs, right? So you have very poor UIs in a control systems, right? So that is also there, but they have operating system. Now, but operating system, if you look at this particular previous discussion, right, and we have identified resources also, the system resources. They are primarily, you can say, processor, then you can say memory, then you can say devices, and the most important is files and information. Okay, so there are these four classes of resources that are available. Now, when an operating system manages these resources in a very effective way, then this OS is called as resource manager. This OS is called as resource manager, and the purpose of this particular resource manager, right, is to allocate, right, is to allocate, use, and make it free, right? So is to allocate the resource, use the resource, and whenever the work is being done, you should make it free. Okay, so but before this, it also important is it also track. Okay, so track, allocate, use, and free, make it free. So this is how this resource manager has to work with, right? So it must have to track the resource which is available or not, allocate the resource, then use that resource, and once the usage is done, the resource manager frees that particular resource also. So OS is also called as resource allocator, which is managing all the resources dedicated into a system. It decides, and it also involved in deciding the conflict request for efficient and fair use. Okay, means what, like, say, for example, if I say I have a certain type of resource, conflict means, like, take a case. I have a resource R, and there are U1 and U2. Okay, so there are two users, U1 and U2. So, or user process 1, user process 2. So both request for this particular resource. Okay, so and both needs these particular resource are in order to complete their work. Okay, so there is a conflict. So, like, here, in case of this, to decide a conflict, like, there are certain methods that can be adopted. Okay, well, like, if suppose my method is FIFO, FIFO, first in first out, means whosoever request first, this R is being allocated to that, provided that once the task is over, this R is being released by that particular user process. Okay, so in order to decide the conflicts in between the use, you need to decide a shared mechanism for fair and efficient use of this. Okay, at the same time, operating system is a control program which controls the execution to prevent the errors and improper use of a computer. Use of computer in that case, this improper must be, instead of computer, this improper use should take this improper word for resource, for a resource, right? So which means that, say for example, uh, I am a user process one, right? And I need resource type R1, I need resource type R2, and I need resource type R3. So I have three resources right with me. So it is agreed that you should free this particular R1, R2, R3. You should free this R1, R2, R3 once my task is over. Means once this user process finish its work of using R1, R2, R3, you should free. But if you see that this particular user process has kept these particular R1, R2, R3 allocated, right? Allocated, right? And not ready to free, not ready to make them free. Okay, them free. Though their work is over, so or they though their work is over or they no longer required. Okay, no longer required. So if this is the condition which is happening, right, that the process is no longer requiring a resource but still holds that particular resource, it is improper use actually. It is improper use. Hmm? It is improper use. And moreover, the user process, say user process 2, user process 3, user process 4, right? So whatever the process that are available in my queue, those are requiring those R1, R2, R3, they are not able to get. Okay, so means what? These process remains in the wait state only, right? So I'll come to this particular thing, and more detailed discussion we'll have on to this particular case, right? But if such a condition is happening, the OS has to intervene into this kind of mechanism and will restrict the user programs in order to do such improper use of the resources. Okay, so in that way, operating system is also called as a control program, which controls the execution of the program to prevent the errors as well as improper use of the resources that are exist into computers. So I hope this is clear.